Right, so now we're on the Grandmaster video for Chapter 7, Section 1. This video we're going to deal with equations that are not expressed in slope-intercept form. Okay, because that could happen. For example, here I have 4x plus y equals 5. Okay, well, you don't want to jump the gun and say, oh, my slope is 4 because that's the number multiplying x. We can't rely on that just yet because the equation is not written in this form, y equals mx plus b. It's only when the equation appears like this, okay, that you can use the technique that we've just covered. So, to get the y by itself, all I have to do is effectively remove this 4x term. Now we don't do that by moving it over to the right-hand side. Okay? In algebra, you never move things. Okay? Because to move means to contradict the notion of what you do to change one side, you must also do to the other. Okay? This is a positive 4x. So the only way to get rid of it is to subtract it from both sides. Some people write it next to the numbers, some people write it below. There's different techniques. Okay, I like to work down, so 4x minus 4x, that's just gone. So now I have y equals, see how I'm lining up everything? And this is 5 take away 4x. Well, I can't simplify that. Those are not like terms. Okay, technically this is good enough. Okay, even though these terms are written in different order, I can clearly see now that this is the slope and that's the y-intercept. But just for fun, let's write it precisely in mx plus b form. So you can change the position as long as you don't change the sign. So this is negative 4x, so I have to keep that negative. There we go. This, however, this is positive 5. Okay, so I have to put plus 5. Okay, so now it's in the form that we want, so therefore the slope is negative 4 and the y-intercept is 5. Right, next, negative 3x minus 7y equals 0. Okay, so if you want to express this in slope-intercept form, so y equals mx plus b, we need to isolate the y. Well, not only do we have a negative 3x to contend with, we also have a factor of negative 7, right? That's multiplying this y. So let's deal with this one first. So negative 3x, I can take care of that by adding 3x to both sides. Okay, so however I change one side, I must do to the other. Okay, so negative 3x, well, these cancel out. So I'm left with, don't forget the sign, negative 7y equals, and 0 plus 3x, well, it's just 3x. Okay, well, we're almost done, but again, we want to isolate y. So I have to get rid of that negative 7. Well, the negative 7 is multiplying the y, so the only way to undo that is to divide. So I must divide by negative 7, which means I must divide this side by negative 7. Okay, so these negative 7s cancel. Now when I say cancel, it doesn't mean they're disappearing off the face of the earth. It just means they're actually reducing to 1 over 1. Okay, well, 1y over 1, that's just y. That's why we say cancel. Okay, all right, can we simplify this at all? Well, 3 over 7, that is a fraction that is not reducible. Okay, so we don't have to worry about that there. We have a negative in the denominator, so usually by convention, we either put the negative in front or the numerator, that's fine. The x is in the numerator, we can leave it there, or we can bring it to this side and kind of float it in the middle. That's usually how most textbooks would write it. So they would likely write the answer negative 3/7 times x. That's likely how you would see it in a textbook. But the negative could be up here, or you could just leave the x in the numerator. It's totally up to you. All right, so the last one, negative x plus 2y equals 10. All right, so let's isolate y. So to get rid of this negative x, I'm going to add x to both sides. Okay, so this leaves me with positive 2y, but because there's no term in front here anymore, I don't need to write the plus. That just is 2y. Now, what's 10 plus x? Well, that's just 10 plus x. There's nothing I can do. Those are not like terms. Okay, so lastly, we have to get rid of this 2. So this means 2 times y. So the only way to undo that is to divide by 2, which means we must divide, there we go, the entire right side by 2. So these cancel because it becomes 1 over 1. So I get y equals. All right. Well, how do you divide both of these terms by 2? Well, we can actually just divide them one at a time. So this is positive 10 divided by positive 2. We know that to be 5. Okay. Here we have positive x divided by 2. Well, we can't do that. Precisely, we can't, and there's nothing to reduce. If it helps, you can imagine there being an invisible 1 there. So 1 over 2, that's certainly not reducible. But everything's positive. So, come on, you can write. There we go. That's going to give me 1x over 2. Okay. Normally we won't write it like that. And I'm going to also change the order of the terms. Okay. You're more likely to see it like this. 1/2 times x plus 5. All right, so the first critical thinking problem. For each statement below, determine the dependent and independent variable, and then write an equation to represent the statement. So, first situation, we have a rewritable Blu-ray disc. Contains 1024 megabytes, which is actually 1 gigabyte, of data stored on it. When new data is added, the total data, D, in megabytes, at time t, increases at a rate of 55 megabytes per second. Okay, so that means we already have a gigabyte of data, or 1024 megabytes, to start with. But as we write more data, okay, we can only write 55 new megabytes of information each second. Okay, so we have two quantities going on here. One is time, and the other is data. Well, which one is independent, which one is dependent? Okay, well, it wouldn't make sense to say that the time depends on the amount of data. We would say that the amount of data depends on how much time has gone by. Okay, so therefore the independent variable is time, which we use the letter t. So the dependent variable is the amount of data. So that's d. So this is like x and d is like y. Okay. All right. So how can we write an equation using d and t, linking them together? Well, we know that the amount of data, we originally start with 1024 megabytes. Okay. But as time goes on, for each second, we add on 55 megabytes. Okay, so 55 megabytes per second, multiplying the amount of time, okay, this part here, this term, will tell us how much data has actually been added. And adding it to the original gives us the total. If you were to graph this, by the way, if this was y and this was x, the 55 would actually be the slope. And the y-intercept, or in this case, the d-intercept, would be 1024. Okay, so I'll actually just throw in my units here. So this is in seconds, and d is in megabytes. All right, so that is an equation that symbolizes or represents this relationship. Next, we have a supply truck. It arrives containing 2,500 liters. Okay, it could be of, I don't know, water. We don't know. Which is then pumped out at a rate of 120 liters per minute. Okay, so obviously the two variables we have going on are the volume of whatever substance we're working with and the time that goes by. Okay, so the independent variable once again is time. Okay, remember t, we're in minutes. Okay, and the dependent variable, well, that's the volume. Well, we'll call that V for volume, and that is in liters. Okay, there we go. So we know that the volume, we originally started with 2,500 liters. Okay, but for every minute that goes by, we don't gain, we lose 120 liters. So we actually have to subtract what's being pumped out. So that's why it's a minus. Okay, so for every minute, we lose 120. So if we multiply that number by however many minutes, okay, this term here alone will tell us the volume of water that has been pumped out. Okay, so 2,500 liters minus 120 liters per minute times the number of minutes, that will give us the volume of water, or whatever substance it is, in the truck at any given time. If you were to graph this, the slope would be negative 120. That's very steep. And the y-intercept would be 2,500. Okay, you don't have to do this, but there's nothing wrong with changing the order of the terms, as long as you don't change the signs in front of each term. That's positive, so I must put plus. Okay. This is not necessary, but there you go nonetheless. Okay, when graphed, the equations x plus 5y equals n and 5x minus 2y equals 12 have the same y-intercept. What is the value of n? Okay. Now, there are different techniques that you can use, but I will show you one of them. Okay, so we just need to solve for n. Okay, so this equation is incomplete. This equation, however, is complete. The only problem is it's not written in slope-intercept form, so we might have to take care of that. We are told, however, that these two equations, okay, if we were to graph these lines, they have the same y-intercept. So therefore, we're actually going to have two lines that intersect at the same point. And then we can use that information to find the value of n. Okay. Well, one thing we can do is let's just convert both of these equations into slope-intercept form. Let's see what happens. So x is equal to, x plus 5y, that is equal to whatever n is. All right, so let's get this in slope-intercept form. So I'm going to subtract x from both sides. I'm just not going to write it this time. So 5y equals n, take away x. But now I need to divide everything by 5. I'll show that. Okay, so that gives me, because these cancel, 5 equals n over 5. Well, the best I can do is write that as n over 5. Okay, take away x over 5. Well, that's the same as take away 1x over 5. So that is minus 1/5 x. Okay, you could just forget about that 1 and put the x in the numerator. That would be totally fine. Okay, but we can see that this here, that is our slope of negative 1/5. And then we have our y-intercept is n over 5, whatever that is. So let's now work with this one. I'll do that in red. So we have 5x minus 2y equals 12. Okay. Well, there's nothing missing in this equation that we need to worry about. So let's just rewrite it in slope-intercept form. So let's solve for y. Now notice how this y term here, it's negative. So another option is to actually express y on the right-hand side, making it positive. You can do that whatever you want. A lot of kids, they always like to keep the variable that they're trying to target on the left-hand side. Doesn't matter. So here I have positive 5x, so I'm going to subtract that from both sides. So that leaves me with negative 2y equals 12, subtract 5x. So here's where some people say, oh, you just move it to the other side because it looks like it moved. Okay, but really it didn't. Okay, I subtracted the 5x from both sides. I just didn't actually show it. So it's important to remember that when you're doing stuff like this, you're not actually moving. Okay, so it's actually a mistake to say move, because in algebra we never move. All right, it just looks like it moves. So that's why sometimes people say it. So we need to divide everything by -2. Okay. So these cancel. Oh, what the heck? I'll cross them out. I'll cross these guys out too. Why not? All right. So this gives me y equals 12 over -2. Okay, that is reducible. That gives me -6. Okay, got to really be careful with our signs here. Now I have -5x over -2. Well, I know a negative over a negative is positive, so I'm going to get my positive sign in there right now. I know that 5 over 2, that is not reducible. So I'm just going to leave this as 5 over 2. Okay, you can keep the x in the numerator here with the 5, or float it over here. Okay, so here's my line. Its slope is 5 over 2, and the y-intercept is 6. So I think we have enough information now to figure out what the mystery number n is. Okay. Now we were told in the beginning of the problem that both of these lines, so I'll box them here, they're different, but they have one thing in common, and that is their y-intercepts are the same. Okay. Well, this y-intercept is -6, and this y-intercept is n over 5. Okay. Well, the only way those can be the same is if they're equal. So therefore, we can extract a new equation. We know that n over 5, that must equal -6. Okay? If these two expressions were not equal to each other, then there's no way we could say that their y-intercepts were the same. All right? So this is a very simple equation. All I have to do is solve for n. All right? So it's being divided by 5 right now. So all I have to do is multiply both sides by 5. Okay? I can put it out in front here in the middle. Do not put it on the bottom. Then you're dividing again. So I'm just going to multiply that top by 5. And I'm going to multiply -6 times 5. I need brackets here. I don't need them here. All right, so 5 over 5 just becomes 1 over 1, so I'm left with n. Okay. And we get -6 times 5, -30. So we are done.